Welcome to qnawire.
Let's look what happens to our final angular momentum. Does it change? How? Okay, there are two things to consider. So first of all, the question says there is no torque acting on our disk. So if there's no torque, that means that angular momentum is conserved. Angular momentum being L is conserved. And then from that assumption, we can jump and say, if angular momentum is conserved and moment of inertia I must decrease, because we know that as temperature change is negative, the radius of that disk or diameter will shrink, so radius will be smaller, then angular speed must increase. And you'll kind of see better in part B when we actually solve this. Okay, so if angular momentum is conserved, that means that L initial equals to L final. That means that I initial angular velocity, is equal to I final omega final. And then we know that the moment of inertia, for a disk is 1/2 mr initial squared. Omega initial is equal to 1/2 mr final squared. Omega final. The m's, the r's will cancel. We know that our final r, based on linear expansion, will be r initial times 1 plus alpha delta t omega final. The r initials will cancel out with that square root. And so where you can just plug in our numbers and solve for omega final. W initial is 25 radians per second is equal to 1 plus alpha for copper is 17 times 10 to the negative 6 inverse degrees Celsius. Delta T is 20 minus 850. That's squared, and then omega final. You find that omega final is equal to 25.7 radians per second.